Hey everyone, how are you doing today?
I don't know, Guy, because it is just a little bit too early. But I haven't had anywhere near enough coffee. I haven't had anywhere near enough anything. So this stuff might work today. I mean, the camera is already on the blink, so like it's a good start, right?
Nick,
Welcome.
it's you, man. Everything is gonna work and everything is gonna be wonderful. Let's do this, buddy.
Well, yeah, okay. Let's give it a go anyway. Okay, so what we're going to look at today? Well, we want to look at how you can use Terraform Boundary and Vault together to enable your application developers to have a secure and repeatable deployment. So what that's going to encompass is kind of looking at a couple of sort of key concepts, which is how do you gain access to a database? How do you provide credentials to the database for me as an individual? And how do you provide credentials to a database for a Kubernetes application? We're going to use Kubernetes because like all the things, but you know, the same principle applies if you were using Nomad or any other application or service runtime. So this is our example application. This is what we're going to kind of run through here. We have a public load balancer. We have a microservice which is written in Minecraft, and I will get to that in a moment. But yes, you did hear that correctly, and it isn't early, and I didn't make a mistake. But we're also going to have this Cloud SQL database, and that's kind of like a typical sort of bounded application setup. Now, to kind of provide credentials to the Cloud SQL database, we're going to use Vault. Vault is going to dynamically generate those credentials. To get access to the database, because actually, there's no public access to it, we're going to use Boundary. And you'll see how that works as well. And well, I'm saying how it works, it might work. Are you ready to dig in, Guy, bud?
It's gonna work, my friend. Let's do this.
All right, okay. So the kind of the key thing that we're trying to solve here is a problem of application access, and we really have two problems, right? The sort of the secure network connectivity, how you provide authentication credentials. I don't want to kind of dig into slides. I don't want to kind of do any of this. Like, should we just do some live coding, Guy? You fancy doing some live coding?
Let's do it, buddy. I mean, what's the worst that could happen in public access to all your databases?
There's a lot that can happen that would be terrible and bad. Don't worry about that. I made my career around that. All right, so let's open up my IDE here, and I promised you that we were going to building this in Minecraft. As you can see, it is a beautiful morning in Minecraft. We've got HashiCorp towers over there, and well, I need to just head over to the server room and I can start building. Oh, not that. That's yeah, you didn't see that. We
Easiest
can start
commute
building this
ever.
out. That is a bat. I don't quite know why there's a bat in my server room, but never mind. Fish tank. That was where security was, but we removed the security because it's a demo. All right, now what I'm going to do is I'm going to build a microservice in Minecraft. Legitimately a fully working microservice in Minecraft, because the way I see this is that Minecraft is written in Java. A lot of the financial institutions write their applications in Java, specifically Spring, very popular. Therefore, all financial institution applications are written in Minecraft. So we want to kind of follow that pattern and build a best practice. So the first thing that I'm going to do is I'm going to put down. Really? Okay. I'm not. The first thing I'm going to do is I'm going to put down a block, a Minecraft block there. And this is going to be my web server. So I'm using some code generation now. What I want to do is I want to take the request from the web server and I need to send it to the database, which is over here. So how am I going to do that? Well, this is quite simple, and anybody who's programmed in microservices Minecart for any length of time will know exactly how simple this is. So what we need is a dropper, and we're going to pop a dropper up there. So the request is going to go up here into the dropper. Okay, you with me? And then what's going to happen is we're going to go from the dropper. We are going to go into a hopper. If I had a hopper, which I don't, so let me just grab a hopper. there is method to this madness, trust me. And once we've gone into the hopper, we're going to go into a minecart. The minecart is going to scuttle along the track here, and it's going to send the request into the database. This is similar to as if you were building an asynchronous queuing system in any form of sort of not very clever language. But anyway, you know, let's build this out. Okay, so I need to build myself my request queuing method. So the request is going to go up this into the hopper. The hopper is going to drop diamonds, because we're using diamonds for our request, into there, over to there. Now, we need to configure our database. So we're going to listen on port 8081. We are going to use a path of /, and the method we're going to use is get. I'm not going to configure for TLS, so let's just save that up. Now, the other thing that needs to happen is that the request also needs to trigger the minecart, and the minecart's working on a powered rail. So anybody who's used Minecraft will know all of this good stuff. So what we're going to do, because we need to make sure that the request drops into the minecart before we send the minecart off. So we're going to put a little bit of a delay in here, and this is the equivalent of like time.sleep. But we're just using a repeater. Anyway, let's see if this works. And I'll be honest with you, I have incredibly low expectations. But we can see this. So let's get pods. I already have my dev environment running. So let's do get svc. We're going to get the services. I am going to grab the external IP of this. I'm going to grab all of the external IP of this. And I'm going to curl it. So it's going to be that, and it's going to be 8081. Oh, and it's worked. Okay, so the minecart is off. It goes up there and it drops the request into the database. So, I have literally, this is internet connected. There's no smoke and mirrors here. This is real. But I have a problem key. And my problem is that I've hard-coded my database credentials. And we all know that is a terrible idea. Should we fix this?
Let's do it.
All right, let's fix this. So how are we going to fix this is what I hear you cry. And the way that we're going to fix it is we're gonna write some Terraform. So let's dive over to the Terraforms, and we can start writing some Terraform. So actually, let's just quickly pop up a diagram. Now, you probably watched some talks and you've seen some stuff going on here, but we're going to be using Vault. Guy, can you give us a quick 101? What is Vault? How does it work? What are the things we're going to use in Vault?
Yeah. So Vault is our secret management solution. It's the way that I like to define it. It's like it's really good at three things, right? And where it all started is with static secrets. Basically, you have anything sensitive that you want to store in a secure enclave, right? So that's kind of your KV secret engine. Well, but when do you actually need your secrets? Well, you need your secrets when you're going to use them, right? So kind of what the evolution of Vault then led is sort of, instead of just storing a secure secret, if that makes sense, is you can generate it on the fly, and that's called the dynamic secret engine, right? So instead of just putting things in Vault, you can give Vault the ability to create things for you. So when you want to connect a database or a cloud credential or a PKI certificate or SSH, just go, hey, Vault, give me some credentials, and Vault are going to create those on the fly, and they're usually like short-lived and time-bound and discardable. So, people can't go dumpster diving for secrets and things like that because they're not going to be valid.
I mean, people cannot go dumpster diving for secrets in my code anyway, Guy, because a lot of people say that my code's like a dumpster fire. So therefore, that means that all of the secrets will have been incinerated. I probably write the most secure software on the planet. Leaving that aside, let's get into this. Now, what we can kind of see here is we're gonna build this out in Terraform, but we're gonna create a database secrets mount. So the kind of the first part of configuring any of these bits and pieces inside of a vault is we need a database secrets mount, and the mount contains the connection. What's kind of going on here, Guy?
Right. So this is the way that those dynamic secret engines work is via a mount, and the mount is the connection to the database itself, right? So this is like, okay, how I reach out to the resource where I'm gonna then create those credentials, right? And that's across the kind of, this is how Vault works, this is how the secret engine works, this is how the auth method works, right? And with the mount, you usually have one or more roles, and that's up next, and kind of, and that is how, well, as the name suggests, right, it's the RBAC. It's how we separate what we're gonna actually do, right?
So like this, right? Like, so I'm going to define a role. This one is an importer role. It's obviously very, very permissive because it needs to be able to create tables and stuff. But we specify the TTL, so we can actually sort of reduce risk by controlling the length of time that the credentials are available for.
But you forgot your revocation statement again.
Look, I didn't say this in production code. Like, I think caveat with any of my demos, which is basically like, do not run this in production. This is for information. Look, it's early. All right, let's carry on. He didn't say that. So next thing we need to look at is kind of building out some more roles, because ultimately, I mean, that's the same one, but ultimately we want to be able to do this. We want to be able to leverage Vault to be able to provide very granular access. The application should only have the access that it needs. So for example, here I have my importer. You know, I'm kind of granting a very, very permissive kind of, you can do anything approach with the importer, but the reader is very, very limited. It can only grant select. And we're going to kind of do that. And we're going to kind of build, you know, these things out. Now,
and it is the best. Sorry to interrupt you, Nick. It is best practice. It's one of the features of roles. Kind of, you use those very like zero trust mentality when it comes to access. So if you just need to write, you only have write method. If you just need to read, just have read method. Right? There's no reason to have a lot of different grants or capabilities if you're just going to use one.
Yeah, and it makes it really easy, right? Like, and I think that's the sort of the key thing for me. Okay, so let's work out how we can actually use these things. So what we kind of want to do is, I've got a Kubernetes deployment here, which is defined just in you know, it's Terraform, but it's basically just a sort of Kubernetes manifest. And we're going to take this deployment and we're going to inject some secrets to it. Now, when you're kind of injecting secrets into Kubernetes, there's two things that you can kind of think about. One is that you just want to inject secrets and set them as environment variables. And, you know, that's fine, right? Like the problem with environment variables is they never get updated. So you need to restart the pod. So that's one thing to think about. The other thing is you might want to just inject them as a volume. So you can inject the secrets as a volume and it'll just put it as a file in a folder you specify. The thing you need to think about there is, can your application pick that up? Do you need to modify your application? So there's a number of different approaches to do this, but the key thing that you need to do, I think, is that you need to have the very sort of specific mentality that the TTL on the secret will change. It could expire before the life cycle of the application. So we're going to use the Vault controller, the Vault operator. The Vault operator will manage fetching the secrets from Vault, popping them into Kubernetes secrets. It'll keep them updated. And if we need to, so we can get it to automatically restart our pods in the instance of the secret changes. It's pretty awesome. Now, I've just defined a sort of a blank secret there as a placeholder that I'm going to use to kind of put sync my Vault secret into. But the thing that I need is a policy. And this is the key thing, right? We need to be not only granular about what is the composition of the secret, as in what can it do, but what can you access inside of Vault. And this application only needs access to that dynamic secret. So we're only giving it access to that dynamic secret. And the way that oh, sorry, go on.
So now it's that zero trust mentality to Vault itself, right? So if I only need to access one secret, I'm just going to access that secret. I don't need, because it's a secure enclave, I don't need access to any other secrets as well.
Yeah, exactly, right. And I do apologize if I'm kind of a little bit distracted, but just to add a little bit of additional pressure, I decided that somebody should be coming and fitting scaffolding above my head today, so I can't really hear anything. Never mind. We're going to do this Vault Kubernetes auth backend role. So we need to be able to allow the Vault controller to authenticate against Vault to fetch the secrets. And the way that it does that is that it uses a service account inside of Kubernetes. And what we're doing here is we're basically just specifying that link. So we're setting up on the backend role the ability for a service account, which I've defined here, somewhere here, to be able to authenticate against Vault. And when that service account authenticates against Vault, it can get the policy, which is referenced here, which is this policy there. And we can be very specific about that. And then, we can have a devolved approach to this. It's okay for application developers to define these sort of back-end roles because it's their secrets, their application. And as an operator, you can be very permissive and sort of about what I can do inside of the Vault cluster. So the next thing that I need to set up is I need to set up some specific configuration for the Kubernetes operator. And we're going to use this Vault auth. So let me just quickly show you the CRD of this, because it is a custom resource definition. Now, what we have is this. It's Vault auth. We're going to give it a name. And what we're basically specifying here is we're defining an authentication mechanism for the operator, not for Vault, for the operator. So the operator knows that it can use this Kubernetes role and this service account to authenticate against Vault. And we can kind of specify the namespace that the auth mounts in and all of the various other bits and pieces. The Vault connection reference has already been configured. That points to our Vault server. So it's basically just the address of the Vault server. And then once we've kind of got that configured, what we can do is we need to define a cluster role. Now we need to define a cluster role because the Vault operator needs to take that service account and use it to authenticate against the Kube API. So we just need to give it the auth delegated permission to do that. And then we can actually define the secret itself. Now, this is the secret itself here. Vault dynamic secret. Again, let me show you the CRD, because if you're not familiar, like looking at this wrapped in Terraform is probably a headache that you could do without first thing this morning. But here it is. So we've got Vault dynamic secret. We're giving it a name. We are specifying the mount. So this is where the secret lives. In this instance, we're using our Minecraft dev database that we created earlier on. And then the path. Well, in this instance, it's creds writer, because that's how you go about creating dynamic secrets with the database endpoint. And the destination. So I want to put the contents of that secret in from Vault into this Kubernetes secret here. And because I've already created it, I'm kind of specifying create false, but the Vault operator could create that for you as well. You do need to give it permissions. Anyway,
and what I love about this is that, like, if you think about it, right, what we're doing was we're changing the seed of the secret that the application is going to use without changing the app itself, right? Your cybersecurity team is going to love it. Your cybersecurity insurance is going to love it, because it should make your premiums go down. But you're basically enhancing cybersecurity without actually kind of having a lot of work to do, right? Just saying, like, okay, instead of seeding it by a long lived or by hand or within a YAML code, we're dynamically generating it from Vault. So
yeah, absolutely. And there's a few different steps that we've had to add here, but it's easily templatizable. I mean, you could quite simply build a Terraform module to make this a pattern which you use all of the time. So now we've got all of that set up, what we can do is we can actually go ahead and add that secret to Kubernetes. So the first thing we're going to do, oops, we're not going to do that. That is absolutely the wrong thing to do. I've just done it again. I mean, I did say it was early. Okay, we're going to specify a volume mount. I'm losing my voice. Now, the volume mount is going to use a Kubernetes volume that I'll define in just 2 seconds. And it's going to put the mount path at etc. DB secrets. So what that means in principle is that any of the keys inside of the Kubernetes secret is going to be mounted as a file in etc. DB secrets like that. And then we define that volume link itself, and we're just going to put that just here. So bear with me. And I copy pasta this, and it looks like this. So again, there's nothing unusual here. This is just standard Kubernetes stuff. All right, Guy. Now is the time to discover how many typing mistakes I've made. I'm going for substantial. TF YOLO, that's the way that you apply Terraform code in production, right?
Always.
I mean,
what's a read-only Friday, right?
Read-only Friday, that's that. I tell you, that's for the unambitious. That's what a read-only Friday is for.
That's for people who enjoy their weekends.
Exactly. I think the key thing is, though, that when you get used to kind of having patterns and practices and being a little bit flippant about the way that I'm kind of doing some of this stuff, but it is very feasible and very reasonable that you can make changes on a Friday. Like, you just need the checks and balance and the automation. And we don't have time to do that at 25 past 8 on a, I don't even know what day it is, Friday morning. But anyway, okay, so this is going ahead and this is getting created, or at least we think it might. And what it's going to be doing is, if I pop over to my Vault cluster, I'll be able to see here that, we've got the roles. Okay, so this is now working. These are the roles that I've created through my Terraform code. We can kind of see those access methods as well there. And hopefully this will, okay, so it's still, well, so far so good. I mean, it hasn't failed yet. That is generally a good sign. The secrets have all been created. We're now creating and updating our Minecraft deployment, and that is now done. That surprises me that worked. I will be 100% honest with you. I'm not going to lie. Let's have a look. So we kget secrets, and we do have our secret there that the controller has created. Describe secret that -o YAML dash format. Hey, the what? I think you're wrong. Flag format. Come on, just. Hey, oh, it's all gone horribly wrong. It is literally just going horribly wrong. Oh, I know why it's doing. Hey, get secret. Why didn't you correct me?
It's Friday morning.
I must have typed this 1,000 times.
-o?
Yesterday. Yeah, I can't remember. It is -o.
You have to describe again in kget.
Oh, you. I mean, to be honest, this is an interesting segue whilst we're waiting for the deployment to start. So we're not really wasting any time here. But, you can see there that the Vault has created this secret and it's populated those values in base 64. So if I echo that and then I base 64 decode it, 64-D, you can see there's the name of my secret. Now, if I also bounce into the pod, so let me just grab that, exec -it that bin bash. Wow, just wow. And then we go to etc. db secrets. You can see there that those are the files. So if I just cat username, we can see that there. And I'm going to cat password too, because, you know, I feel 100% comfortable in sharing that database password with the entire world because I know it's got a short TTL on it. Okay, right. We're nearly done. We have just a couple of little last bits and pieces, and that is, how do we go about configuring access to this data store for a user? And the answer to that is we're going to use Boundary. So we're going to write some more Terraform configuration. Guy, I'm defining here a credential library. What is a credential library in Boundary?
Right. The credential library is kind of where you store credentials, right? In Boundary, you have two main ways to store credentials, right? You either have a native enclave, or you can have that integration with Vault, right, for the dynamic secrets. So whenever you want to actually connect somewhere, right, you don't need to bring your keys with you. You can just use what is there already, or have Vault generated for you.
Awesome. And I'm kind of like just showing a quick sort of topology here, but ultimately Boundary is that private access management tool, right? It kind of links into Vault, it links into your Kubernetes, into all your existing infrastructure.
Yeah. So kind of, if Vault is the secret management, like Boundary, it's the love child between Boundary and Consul, right? If Vault is your secret manager, Boundary is kind of that access management. It helps a way of getting those credentials from Boundary and creating the connection from you to the destination where you want to go.
Yeah, that's
in
awesome.
This case, the database.
So lastly, I'm just going to define a target. The target is my database. I'm going to define a role because the role is giving me as a user access to Boundary. I apologize about the noise. I can genuinely not hear myself think here. And we're going to run this again. Okay, so whilst this is running, let me show you my Boundary setup. We are nearly done. So I have my Boundary server here running. Again, I'm using HCP. I'm just running everything on the free tier because it's super easy and super convenient. And we can see here that, so we've got organizations. Now everything in Boundary, like it's scoped by organization. You can have organizations, and then you can have projects. So everything is possible to scope incredibly narrowly, right? So a target is linked to a project, to an org, and like it's possible to can make it really sort of, you can cut it up however your organization needs to.
Yeah, and what's great is like it's not only for database access, right? And because it is just access management, and you can talk to everything on TCP, so it is reused across different use cases, right? So you can talk databases, you can talk SSH, you can talk RDP, you can even talk web applications, right? Because and we're going to improve that further on, but I shouldn't say that for now. So you can separate that like per team or per access, like what you need, and you can again really scope it to that access that the team needs and that you need, and you don't need to make it like you came into Boundary, you have access to everything. No, just.
But you can see here that the target has been created. So now if I open up my Boundary desktop tool, which I've just opened there, then let's just make this a little bit bigger so you folks can see it. You can see that I've got that. So I'm going to hit connect. Now what Boundary is doing is Boundary is making a connection to my remote database. It's exposed that connection on localhost. It has automatically spoken to Vault and grabbed me a username credential, and that should be enough to log in. So let's just see if that is actually true. So I'm going to connect here. I can never remember if it's big H or little h, and anyway, localhost 5432, and then I'm going to specify my user. Now my username is this. Now I'm using Azure Cloud SQL, so I need that plus the name of the database. which I need to just grab from somewhere else because I can't remember those things. And we're going to paste that into there. And then we need to specify the database, which is dev, and that might work. Let's have a look. Oh, yeah, that's of course because it's, of course, you specify localhost and port separately. Now, let's have a look. Okay, so this is good. It's asking me for a password, which means that I've actually done something right. I'm going to paste that password in there. Oh, it's having a good think. I probably typed that password in wrong, I'll be honest with you. Come on. You know, this is... Oh, that's not the right user. Okay, Guy, I just don't know. I'm typing something in wrong here. I can't function. It's just too early.
Shall we start a new connection and then start over again? We'll end session or create a new session and get it from there.
I think my problem is that I'm trying to use Windows here. And
that's always a problem. There we go. You're just doing it for the tension.
See, I told you I was just copy pasting the password in wrong because I don't know if it's Control-Shift video control.
It's clickbait. You're doing it for the YouTube shorts, right?
Absolutely right. Like, look at this incompetent guy. Okay, so now we've got that. They're running. Let's do select star from counter. So, you know, we've got access to the database there. I can't update this because of the narrow scoped permission that I've got. I mean, I can try that update counter set count equals 1. Okay, see, permission denied. Now, the nice thing about this is that if I look at it from an administration perspective, and we are done because those building work is getting really noisy for me, you can see the sessions here. So the administrator can see every session that I have in the system. That is my current live session. I'm going to hit cancel, and I'm doing this in the UI, right? In the boundary UI. Let's go over here and let's have a look at what's happening if I can find the window. And then let's just do select star from counter. It's killed my connection. So that's a really nice feature that as an individual, I can use my boundary CLI to create a connection, but we can have sort of processes or anything which is running on a kind of an administrative level, which allows me to sort of terminate those connections for, you know, for whatever reason. Oh, I'm exhausted. I think I need to go and have a cup of coffee. It has been a pleasure presenting with you, buddy. I want to say thank you to absolutely everybody who is behind the scenes at HashiTalks. I want to say thank you to our ASL interpreters because you are doing a fantastic job if you can keep up with my rambling at this early hour. And, well, thank you to everybody who's watching because for all of the aforementioned reasons.
Cheers, everyone. Have a lovely day, and I hope you're enjoying the event. Yeah, and stay tuned for more great talks. And Nick, always a pleasure to be with you, buddy.
Indeed it is.